Okay, so we got a question right here. Initially, the spring was fully compressed as the toy was released. The head accelerated upwards on its own until the spring was uncompressed. The head then pulled the base upwards and they moved together at the same speed, right? So let's draw out this scenario. The first scenario we have is basically saying that there's a base right here, right? And it is basically like it basically releases, like we know the first question, it was compressed, right? So now we have just released it. Now it will basically, the first scenario says that it will just go up until 1.7 centimeter, like it will fully uncompressed itself, and then the ball is just straight up, right? There's no like this curly things, there's no curly things anymore. This is like a basically a straight line of the spring, right? And then this is our first scenario, and we know that our initial base was basically u2 was basically 0, and then u1 was basically going at a speed, right? This is u1, right? The ball is u1. Now at the second scenario, they basically says the head pulled the base upwards and they moved together at the same speed. So now, because let me draw the base as well, right? So the floor, so now it is going upwards. It's no longer in the base, it is going with the ball upwards, right? So now this is v2, and this is our final velocity, right? So this is v2 and v1, they are both equal, right? So v1 and v2 are basically both equal, right? Because they're going at the same speed upwards together, right? So now let's read the second paragraph that has been given to us in the next page. The student used the electric potential energy stored in the spring to determine the maximum speed of the head, right? So he calculated that initial the maximum speed it gained before it goes upwards, goes into the second scenario, the maximum speed, right? So the maximum speed we have to figure out, he figured out using the elastic potential energy, right? He used basically this formula right here. E is equals to 1 by 2 mv square, right? Square, okay? We can write this as u1, right? This formula has been used for the scenario 1. Now we have the scenario 2. He says the student used the gravitational potential energy gained by the whole toy. Basically the whole toy is basically, it includes the head and the base, right? This one is only for the head, not for the base, right? It is only for the head, so we will take only the mass for the head, right? Over here we take the mass for the whole toy, right? And it's using the gravitational potential energy. So we know that the formula for it is E is equals to mgh, right? We're gonna use this formula right here, right? And then we're gonna basically, once we get the energy from here, we're gonna use it to find the speed of it, because we know that both speeds are equal, right? So we will use E is equals to 1 by 2 mv square, right? This time v, right? Because we need the velocity of both of them, right? To calculate whether their momentum is conserved or not, right? So basically they said determine whether the toy obeys the law of conservation of momentum using the value of speeds calculated in this way, right? The mass is given 6.4 g. Let's write the information that we have been given. We have been given basically mass of the head, right, which is basically 6.4 g. We have been given mass of the whole toy, which is basically 7.2 g, and then we have the maximum height, the max height of jump, basically 1.5 meter. Don't forget to convert this because it is in grams, the masses are in grams, so make sure to convert it into kg, right? I will do it while solving the question. So let's do the first scenario, right? We need the initial velocity, right, for this scenario right here, right? We need this u1. So calculate this u1, basically we will use E is equals to 1 by 2 mv square, u1 square, right? So this is our first, I'm doing the first scenario, right? So now we have the elastic energy from our previous question, which is 0.119 joules is equals to 1 by 2. We have the mass of the head because it's only talking about the mass of the head, as we have stated in the first scenario, right? So mass of the head is basically 6.4. We have to convert it into kg, so we are going to divide it by 1000 to convert it into kg, right? And then we have u1. We have to find u1, right? u1 square. So if you once you have solved this, you will get your u1 basically 6.098 and furthermore more. So this will be basically round off to 6.1 meter per second, right? This is our u1, right? Now for the second scenario we have to calculate, which is basically our second scenario right here. We have let's see, okay, we have to calculate from first we have to calculate the gravitational potential energy for it. So E is equals to m. We have basically mass of the whole toy, which is basically 7.2. Don't forget to calculate into a kg, right? Into kg. So we have to do 7.2 divided by 1000. Then mg, we know that g is 9.81 as according to your it's given at the back of your booklet or your question paper, right? And then you have basically velocity. Yes, you have the velocity right here. So we have no sorry, we have the h right here, sorry, my bad. You have the h, which is 1.5, right? And then once you have calculated this, you will get your answer as 0.105,948 joules, right? Don't round it off yet because you have to use it over here as well. So it's better to be precise, you know. So now I'm gonna use E is equals to kinetic energy by 1 by 2 mv square, right? And then you have your kinetic energy as 0.105948 is equals to 1 by 2 m. M mass is of the whole toy is basically 7.2 by 1000. And then you have velocity as you have to find the velocity, right? So we have the final velocity once you have calculated is basically 5.2. Now 5.2 is for both the ball over here and the base as well, because their speed are same when they're traveling, right? So now I'm gonna do the conservation of momentum here. So we know that m1 u1 plus m2 u2 is equals to m1 v1 is plus m2 v2, right? We know u2 is basically 0, the base is 0, right? So if you 0 multiply by the mass, it basically gives you 0, right? And then you know the mass of basically the head right here, which is 6.4 times 1000. Let me write it here again because I actually did not, because the space was less. So let me write it again, 6.4 divided by 1000, right? And then you multiply it with the speed that we have got 6.098 plus 0, as I told you, like we have use u2 0, so basically this whole thing will be 0 once you multiply it. So your mass of these second, your basically you can write this as, because they are traveling at the same speed, so you can write it as m1, right? m1 plus m2 basically multiplying with v, right? Basically the final velocity we can write this as well like this, right? So m1 is basically our m1 and m2 basically gives you 7.2 by 1000, right? And then your velocity is basically one we have got 5.42, right? So now let's check if they are both equal or not. So once you have calculated it, you will get your answer as 0.039 equals to 0.039, right? So we can basically say the momentum is conserved. m1 and m2 is basically, m1 is basically the mass of the ball and m2 is basically the mass of the base. You can say it, okay? It's much easier to remember, right? So our total basically mass was given over here 7.2 g, so that's why I put 7.2 g by 1000. So we can say our momentum is basically conserved. right? This is your answer.